Hi everybody and welcome to the Kidney Coach YouTube channel. I am naturopath Fiona Chin, co-founder of Kidney Coach and Kaigenesis, a range of supplements designed for people diagnosed with chronic kidney disease. Whether you've got a low eGFR or high creatinine levels, or you're spilling some protein, we might have a supplement for you. And I'm joined again today by the fabulous, the wonderful, the Mr. Dr. Morgan Camp, who I haven't had on the podcast for ages because he has been busy doing some very amazing things that we won't talk about today, but we were having a good brain download before it. But for those of you who haven't heard a podcast with Morgan Camp before, he is you're calling yourself a medical polymath, and I love that because that is very much you. Very much into mitochondrial health, which we're going to talk about today, looking at innovating precision medicine along with AI, global healthcare networks, advanced peptide protocols, definitely complex case resolutions. He is an absolute expert in all things chronic infections like Lyme, mold, SIRS, parasites, and then proactive healthcare pioneering. He's very much in the medical space to watch of all cool things. Is that even a word? I don't know, but it sounds good because that's where I would put you. And apart from that, he's an all-round amazing, genuinely nice guy, genuinely cares about his patients and goes out of his way to make sure that people get well and really understands from a deep personal level what it's like to deal with a chronic disease, which I think gives you an edge over most people. Dr. Morgan Camp, welcome back to the podcast.
Thank you, Fiona, and so glad to be here. Thanks for the great introduction. I'm humbled and always thrilled. I do get to meet a lot of your listeners. A lot of your listeners have reached out to me. Several have become patients of mine, so thank you. It's always a joy and pleasure to meet well-educated people from your channel who listen. You have such a wealth of information and such good interviews with so many people. So I learn a lot listening to your podcast. So thank you, Fiona.
Yeah, no, like I say, people are like, how do you know so much? I'm like, I sit down and talk to geniuses every week. I'm like, I get one-on-one mentoring with all these cool people. That's why I have had an advanced education in the last couple of years. Podcasting. Who knew? I should have done this ages ago.
Right.
Now, you've got an amazing presentation that you're going to take us through today, which I'm very excited about. And I'll let you introduce it and, talk about it. But it really is about, I'll let you introduce it. I'm not going to do it justice if I do it.
Well, yeah, it's called the Exercise Intolerance Codes. What is the title? Solving the Mitochondrial Mystery, I believe, something like that. I'm never good with those things.
That sounds right.
I have written a book on this topic as well. It's about 80 to 90% done. So I hope to have that out in the near future. So the idea behind this talk is a talk for people who have had chronic illness and plateaued in their recovery at that 70 to 80% range, where I was for like a decade, where you get better, get worse, get better, get worse, try everything, just get a little better, then get worse again. And why is that happening in a lot of cases? So we're diving deep into the mitochondria to help explain some of that. So for example, you just brought up someone you know closely who can't tolerate NAD. And we'll talk about that just to bring that up and give a little hook for the listeners. So any of you listeners out there who can't tolerate NAD or any NAD precursors like myself, when I first got that, it made me really ill. We'll explain the why of that through this talk. The Exercise Intolerance Code, and this is a talk I gave at the iLads conference maybe a month ago, and it was part of a larger workshop on patients who do plateau and how to help them through that. And so it's especially for patients who get worse with exercise, who maybe have the heart rate racing, feel fatigue afterwards, post-exertional malaise afterwards, these sorts of things. That's really what we're talking about here. And so the subtitle is A Paradigm Shift in Understanding Chronic Disease from Cellular Zombies to Superhuman Recovery, the Three-Phase Mitochondrial Restoration Blueprints. We're going to talk about those today.
Love it.
So today's roadmap, and these slides are originally for doctors, so that's why it says your patients versus you, but it's just as It's just as relevant for all the patients out there. So what we're looking is if you're the ultra compliant patient, why are you getting worse despite perfect protocols? What's the hidden cascade causing exercise intolerance? And I give a hint at that here: senescent cells that are activating the CD38 pathway. They're causing NAD depletion, and the NAD is actually causing more inflammatory cytokines to be released, causing more senescent cells. A 2-minute assessment to know who can exercise safely and who will crash. How to measure the unmeasurable, looking at interleukin-6 and these lactate to pyruvate ratios. And then this was for doctors, what can you do Monday morning? Decide, this is irrelevant for you guys too out there listening, who can exercise, how do you know when you can exercise safely and not? And how to know when you can safely take mitochondrial stimulants and mitochondrial supplements and when not to. Yeah, so there we go. We'll move forward. So these are fictional profiles, but these are a representation of a conglomerate of patients I've had before. So I have Rich, a 61-year-old former triathlete with a history of Epstein-Barr virus triggered chronic fatigue from which he had recovered. He later developed long COVID after his third vaccination. And for 18 months post-COVID, he was ultra compliant with everything. He would originally get better, but then crash days to weeks later, often feeling worse than baseline. So, Rich is kind of typical of patients who a lot of us see. I'm sure, Fiona, you see a lot of patients like this.
I'm like, wow, you just described half my patients that I saw last week.
Exactly, right. They've had 15 to 20 doctor's consults. They got long files. They're high achieving. A lot of them have been really successful in life. And then they've had, they've been taken down by illness and then haven't quite regained that before. And there was a triggering event, something that broke the straw that broke the camel's back, so to speak. And that's usually infection, stress, or vaccine injury. And now they're stuck at 60, 70% of their capacity. And then they have the waxing and waning course, yo-yoing up and down. Mm-hmm. So the pattern that we typically see, and this is something I'm sure a lot of your listeners will listen to, is post-exertional malaise. So you get worse, you feel good, you exercise, you get worse. Chronic insomnia, labs often look normal. Maybe you have some mast cell activation syndrome symptoms. Maybe you have some anxieties, depression symptoms. And then they'll get better, then they get worse, then they get better, then they get worse. You go to functional medicine doctor, they give you CoQ10, PQQ, methylene blue, NAD, and you get worse. Anxiety, insomnia, more pain with that. Why is that happening? You do even just a little bit of exercise, you get worse. Fatigue, brain fog, insomnia. Each intervention cycle, you get excited, you get a little better, then worse again. This happened to me for at least a decade. Every miracle treatment you try, every influencer who says you need this, you need that, you try it, you get a little better, then you get worse. Yeah. So what happens? Why are people plateauing like this? So, a lot of doctors are treating these successfully. So they're getting rid of the Lyme, the viruses, the parasites, the infections, clearing the mold toxins, getting the gut health improved, getting the immune system improved. Patient feels better, labs look better, yet patient's stuck 60, 70%. So here's a list of what all might be missed in such a patient. This is probably not an all exhaustive list, of course, but maybe it's 70, 80% of what really should be looked at in each patient who has these criteria. The first one I put on here, sort of what we're going to talk about today, is cellular senescence. So this is the hidden problem. 10 to 15% of senescent cells remain even after you've done all this clearing. You got a lot, and I'll go into detail on more of what senescent cells are, et cetera. We'll go into that in a few minutes. Also, you get a lot of cytokines. So these can be tested. So you can get cytokine panels and look for cytokines, interleukin-6, interleukin-1 beta, interleukin-18, TNF alpha. These all can be elevated. You can look for CD38 and genetically. So CD38 is a gene, and you get overexpression of CD38 So you get an upregulation of CD38, and a shout out to Bob Miller. I learned about this upregulation of CD38 from Bob Miller. And what happens then is when your CD38 is upregulated, you're basically destroying your NAD faster than you can take it. This creates the self-perpetuating cycle where senescent cells create more senescent cells, cytokines rise. So these are typically elevated, but these are not typical labs that people are looking at. So I propose in this talk here that one of the best markers to look at, if you can only pick one cytokine, is interleukin-6.
Yeah.
But I prefer just basically I usually get a panel that has all of them. The other thing we want to look at, so again, back up here, what all might we have missed when patients plateau? Mitochondrial dysfunction. So sometimes it is just low NAD. Sometimes it's complex dysfunction where respiratory chain is damaged. I had like severe respiratory chain damage. You get lactate pyruvate ratios off, and this lactate is also is lactic acid. So one of the clues you have this off is that you get a lot of muscle pain, muscle fatigue, especially with exercise, or even just muscle pain, that is there at rest because of the lactic acidosis, basically. You're getting failed mitophagy, so the mitochondria are not repairing themselves. You're getting ATP insufficiency, so you're not getting the cellular energy that you need to meet your needs for, especially your brain and your heart, usually. Clinically, this shows up as, again, exercise intolerance, post-exertional malaise, and just up and down energy. One day feeling better, other day feeling worse. Yeah, and very simple. If you don't have this, if you don't have ATP, you're not going to have energy for anything. The other things you might want to look at, limbic system dysregulation, of course. So anybody with a chronic illness that's not getting better, this is an issue until you fix it. So almost everyone has this problem. So Dr. Neil Nathan's an expert in this limbic system dysregulation and the treating of that. There's a lot of online platforms treating this and a lot of information. I'm not necessarily an expert in this. I've gone through all this myself, but I don't teach it much myself just because there's others who do it better than I. But this is critical for people to understand. This is if you've had a mold issue and you walk into and you think you're healed, you feel amazing. It's been years since you had a mold issue, and you walk into a restaurant, and you smell a musty smell, and next thing you know, your heart's racing, you got brain fog, you feel ill, you're panicking. Well, is the mold affecting you that quickly? It could be. Or is this just your warning system in your body saying, hey, there's mold here, we're trying to alert you? And that can, and it's impossible to know which one it is, but they produce the exact same physiological mechanism. So whether it's real or imagined, your body will have the same manifestation of the illness. So it's important that you heal this. That way, if you no longer have a mold sensitivity or you healed that, you don't get that triggering event when you go into the moldy restaurant. Because this leads to activation of these neural pathways, increased chemical sensitivity, pain amplification, emotional dysregulation, anxiety, depression, trauma, panic, and clinically overreacting, basically. Next is autonomic nervous system dysfunction. So when you have got a chronic illness, you're basically stuck in a sympathetic overdrive state, right? Your HRV is going to remain low. This is where you get symptoms like dysautonomia, POTS syndrome, postural orthostatic tachycardic syndrome, and you can't heal when you're stuck in this one. So how do you monitor this one? Again, HRV testing is a good way to do it. There's a lot of like vagus nerve stimulators that can help you deal with this. Neural therapy helps you deal with this. There's a lot of ways to address that. Circadian rhythm disruption is a big issue that Fiona and I talk about. I know she's a big fan. This is why I got the red light on behind me, because it's late at night here, because I was supposed to be in Hawaii, but I'm not, and instead of somewhere else where it's dark. So,
not that we're sad about this at all.
So we want to minimize blue light at night, because with blue light, we're getting disrupted melatonin, we're getting cortisol dysregulation, we're getting metabolic chaos, and you're getting insomnia, can't wake up, energy is wacky. So I find for especially people with mold illness, this is one of the most important things to fix, that circadian rhythm disruption.
Yeah, I can agree more.
Chronic stress and HPA axis dysfunction, unresolved traumas, chronic stressors, cortisol dysregulation. Best way to measure this is just a 4 to 5 sample cortisol test throughout the day, being a saliva test. Signs of this are wired but tired, anxious, and a big one. How do you react to stress, whether it's emotional stress, physical, et cetera? If you get a call and it stresses you out, and then you need to go take a nap and you're stressed out and can't move, well, that's a good sign that you got a chronic stress issue. Persistent inflammation despite a normal CRP. Again, what you want to do to tease that out more is these cytokine panels, looking at IL-6, tumor necrosis factor, IL-1B, IL-18. You can also measure complement activation, see if that's persistent. Look for mast cell activation, these sorts of things. Mike, this is a big one, this microglial activation. You probably know more about that than I do, Fiona.
Yeah.
There's a lot more information coming out about this. Bob Miller's doing a lot of work on this right now, actually.
Yeah, hard to test, but yeah, microglial activation. Yeah, there's that great book called The Angel and the Assassin, all about that. Fabulous book if anyone wants to read more about that and how that works.
I'll check that out. I haven't read that.
It's a super good book.
So again, number 8, these are reasons why people plateau and don't get better, hormonal dysregulation. So basically what I'm doing is I'm covering every reason why you might be getting better with a doctor and they might have missed some of these things, or maybe they weren't a priority when you first started and now they're becoming a priority because you can't do everything at once, right? So thyroid hormones, sex hormones, insulin resistance, all those fun things. This is the basis. I do this at the very beginning for all my patients.
Yes, you do.
Blood flow, oxygenation. So that's where you get like COVID, having microclotting issues, endothelial dysfunction with certain infectious agents and mold, poor tissue perfusion, basically all leading to low oxygen.
Yeah.
This is one thing I want to do more. And when I was I was interviewing a patient who I give low-dose immunotherapy, and she had a daughter that was in a wheelchair from Lyme disease. They started doing exercise with oxygen therapy on her EWAT. She sent me a photo. Now she's like a teenage model out of the wheelchair, in perfect health, just from doing EWAT at a very regimented pace, and basically not stopping despite the fact that they felt very ill doing the EWAT. You have to do it, but via very precise, regimented structure, and you have to be able to push yourself pretty hard to get through the pain and misery of it too.
Yeah, it's a certain personality that can do that, but generally, as you mentioned, all these patients are ex-high achievers, so.
Exactly. Get a lot of very persistent. The key to getting success in health and wellness is persistence and optimism.
Yes.
And the one thing, number 10, this is the area of more and more people looking at now, but still missed by most of us, is are there spiritual, energetic, existential reasons, right? Maybe you have a loss of purpose with your life or work, social isolation, meanings, fear of recovery, et cetera. I think this is something that everyone needs to address when they're going through a chronic illness recovery.
Absolutely.
Yeah. So here we go. We're going to look more at the mechanisms for basically those top 2 that we looked at, the senescent cells and the mitochondrial dysfunction. So basically, we have senescent cells. Remember, senescent cells are these zombie cells that are producing IL-6, tumor necrosis factor, IL-1B, IL-18, that are then leading to increased expression of CD38, which is depleting NAD and leading to more senescent cells, which is just making this wheel spin faster and faster. So this is something, so this is the newer finding I've had in the last few months, is this right here, the CD38. So if you've got an overexpression of this, you're just going to keep making more and more senescent cells in the setting of high cytokines. So let's go back into senescent cell biology for a second as a reminder to everyone. So remember, senescent cells are these zombie cells that have irreversible replicative arrest, meaning they don't divide. And when cells stop dividing, typically they should die, but these guys are resistant to apoptosis, meaning planned cell death. So they have a persistent lifespan, i.e. zombie-like, they don't die. The issue is they are still metabolically active, but they're not doing anything good. They're non-functional. They're not serving their original purpose as a cell, but they're using resources like your ATP and NAD, but they're not contributing to the health of the ecosystem. As a matter of fact, they are secreting these SASP, which are the chemicals that make you feel like you're dying. Like this is why you feel like why you feel miserable when you have a chronic disease, these SASP factors. And we'll go over those in a second. And when you have this CD38 expressed at a high level, you can get up to 100 to 1,000 times increase, leading to this just massive NAD depletion.
It's crazy too, because they did these studies where they took out zombie cells, senescent cells from say rats they gave them Parkinson's disease, so animal disease model Parkinson's, took out the senescent cells, injected healthy rats, and within 3 days, those rats developed the same disease because of the SAPs and how they can infect the cells next to them. It is like they are proper zombie. You think of zombie apocalypse and all those crazy movies. These cells act exactly this way, and so they will infect their neighbours. So it's it's such a big deal when you've got an overrunning or an overrun of senescent cells and you can't clear them.
Yeah, and you raise an interesting point. We're probably ahead of where we should discuss it, but we'll just do it now so we don't forget. So you just said infect 3 times. We think, so when I was giving this presentation to iLads, and iLads are the Lyme experts of the world. So one of my good friends, he was like, do you think those senescent cells are reservoirs for these infectious agents? They are proven to be reservoirs of viral infectious agents, like even COVID. All like for Bartonella, all signs point to that being very likely. It's not proven, but all signs are pointing in the direction that it very much likely is.
Which would make the most sense of how they can, and I did use that word because I think when I'd read the article, they use the same word. In fact, how they knock onto their neighbours is there must be DNA fragments of these viruses as part of the SAPs, right, that we haven't been particularly measuring. We measure these pro-inflammatory, and this is me hypothesising, so please interject if I'm wrong, but it would make sense potentially with the DNA fragments then when they're blasting out these cytokines and other SAPs that DNA fragment that elicits the response to the disease virus infection crosses into the next cell, and then that cell is reacting or being triggered as if that infection is into that cell. That would make sense, wouldn't it?
Well, and some of these are also intracellular parasites, so they might actually be inside the senescent cells.
Yeah, wow.
And that's perfect because they're in this defense field of the senescent cells that are releasing these SASP right here. So SASP is senescent associated secretory phenotype.
Yeah, that's it.
I always get those. I can't remember which S goes where. I'll have to look it up. Yeah. But here are so basically these are the chemicals, right? So pro-inflammatory chemicals, matrix degrading chemicals, and these are also these are things that we measure. Like if you have mold issue, you measure some of these MMPs. You look at these growth factors, and these growth factors, when they're inappropriately elevated, are what leads to cancer growth, right? And then we got these chemokines, which are an important part of the immune system, and then you got exosome release as well. So normal aging versus post-infectious acceleration. So let me see if I can, there we go. How can I zoom out? Let me see if I can zoom out and get this. Yeah, there we go. Let me see if I can make this a little better on the screen. There we go. So I'll go up and down here. So normal aging's in the darker blue here. So that the top line there. So these are the amount of senescent cells that normally have, should slowly increase. No, this is not this. Sorry, this is normal aging right here. The bottom line.
That would make more sense.
Normal aging is this. You go here, you go here, you go here. Then at some point you get this is usually like age. Is it listed on here? These are on age like 40, 50, 60, starts going up and then it rises. So we got the same person here, say around age 40, they get an infection. Then their senescent burden is rising dramatically above their baseline.
And I'm seeing this. I've got so many teens at the moment that are in there. Like, I've had kids that are bedridden for the last 3 years. So they're like 19 now, and another 27-year-old has spent 7 years in bed from 20. So it's happening even younger now. It's crazy.
Wow. Yep. No, yeah, exactly. This can be at any age. And I think now this curve is just, it's even further apart in certain people. And that's what we're seeing for so many reasons. Yeah. So this one's a little more complicated. So this is the same slide as last. Here's your NAD level here in white. So the bottom is you got here's normal. You got an infection, and this is the higher senescent burden here where I'm tracking here on this line here. This is normal senescent burden down here. So when you get an infection, the senescent burden's increasing. This is normal NAD decline over your life. So it normally drops down exponentially once you hit a certain age. Here's what happens when that same instigating factor, infection, stressor, trauma, vaccine injury, et cetera, hits you, your NAD levels plummet. So they're plummeting. And this is the reason you're getting a lot of fatigue and post-exertional malaise, et cetera, there. So these are two things happening at the same time. The senescent cell burden is going up, the SASP are going up, and the NAD is going down. And this was from 2020. This is from the Nature Metabolism 2020. There's the article there if anybody wants to read it. So remember, senescent cells don't die because their apoptosis is impaired, autophagy is impaired, mitophagy is impaired. And this is some of the mechanisms, just for anybody out there who wants to see those. I don't think we really need to go over that too much. But here's the takeaway here. Senescent cells hijacked all three cleanup pathways. They can't die, they can't clean themselves up, and they can't fix their mitochondria. They become cellular zombies, and at a certain time, senescent cells infect healthy cells at rates faster than they can be cleared, and then the inflammatory cascades are amplified more and more and more. And that's why once you get one problem, you beget another problem. Next thing you know, you got three other problems. And this is why also, if you can't heal yourself at a fast enough pace, you can never overcome that inertia going the wrong direction. And that's why sometimes when you get patients, you're like, well, let's just do one thing at a time every 6 months. Well, if you've got 12 problems in 6 months, you're going to have 15. If you can't move with fast enough speed, you're going to have some challenge there. But you have to be really careful, because if you go too fast, you're going to backfire too. So it's it's carefully orchestrated thing you need to do here. The three principles. So this goes to how we want to start thinking about treating people. I've always treated people from like the bottom up, like, oh, you got this little problem, let's fix that. And then we try to fix all these other little problems. Again, the problem is, if we do it that way, you got 12 problems. And then by the time we fix, 20% of first part, and then you got 13, then we got 14 already. So what I'm proposing in this talk is that we start at a higher level when we're treating people, instead of trying to go pull out the root. Instead, we want to get to the root cause of why everything's spreading so quickly. So that's a lot of what we're doing. So the three key principles, the clinical framework for understanding the plateaus. Number one, senescent cells drive self-perpetuating inflammatory cascades. So they're self-perpetuating. So once you have these, even if you don't get anything else, the inflammatory cascades are just going to keep firing up over and over and over again. Multiple systems, immune system, metabolic, neurological, become trapped in reinforcing loops. So it's persistent inflammation that resists standard treatment approaches. Principle 2, IL-6 being one of these main cytokines is a biomarker that can predict exercise failure. It's also just a good predictor of what we referred to earlier as a plateau. Again, if you only can pick one, in some labs, you can get IL-6 at most of the mainstream labs. You can't get the others, but for most of my patients, I order a full cytokine panel where you can look at more than this. But again, if you've got the same could be said for interleukin 1B, interleukin 18, TNF alpha, et cetera. You have a question, Fiona?
No. I was just thinking in Australia, I think you can't now do the individuals. I had to do an entire cytokine panel to get IL-6. So I think.
Okay. Yeah, here I think at Quest you can get IL-6, but now most of the specialty labs we're getting it more and more. It's so enlightening. You'll see just things through the roof. Mm-hmm. So again, senescent cells release the SAS, one of the main ones, IL-6. IL-6 is then activating a CD38, which is stealing the NAD, leading to just more and more issues. And this is happening, a little more detail on how it's happening. It's happening through NF-kappa beta activation. So IL-6 is activating NF-kappa beta. So if all of you guys have genetic testing up there, you can look to see if you have NF-kappa beta activation or issues with blocking. There are brakes on NF-kappa beta. If you don't have the appropriate braking mechanisms on NF-kappa beta, you'll get problems. But if the NF-kappa beta is overly stimulated or you've got mutations there leading to overstimulation of it, you'll have problems that then directly lead to the CD38 gene upregulation, leading to the NAD overconsumption.
And really, it's Bob Miller's genetic test that's looking at that, because I can tell you most genetic tests aren't checking the NF-kappa beta activation in a standard one. It really need Bob's to do that.
No, it is. Okay. Yeah, he's the only one I use, so that's why I look at that. And one of the best things I use for NF-kappa beta activation, actually, I discovered this is how ivermectin works. So ivermectin works on the pathway that applies the brakes to NF-kappa beta. So as far as I know, I have never heard anybody say that. I discovered that with a patient a few months ago in my research, who she's getting better. She couldn't figure out why. Every time she took ivermectin, like a lot of her symptoms got better. We figured it out why, because it's working on NF-kappa beta and blocking the CD38 gene upregulation, blocking the stealing of NAD and more cytokines.
Interesting. Okay.
For all of you guys who feel better on ivermectin, that might be one of the reasons, because ivermectin is only a mild antiparasitic. It doesn't kill a lot of parasites. So if you're taking it and you feel great, you might want to get your genes tested and see if you've got issues with NF-kappa beta. Mm. So I put some thresholds down here for IL-6. These are more for the clinicians. I think we can skip that for now. We can skip this as well. We've already covered most of it. The main reason I'm suggesting here IL-6 is a good surrogate marker for senescent cell burden is what we're talking about here, because you can't directly measure senescent cells. We don't have, unless you do a tissue biopsy. Again, this is what we look at when we get comprehensive cytokine panels. And what I'm proposing here is if you've got more than two cytokines elevated, two or more cytokines elevated, you likely have a senescent cascade that's active. And then what I'm proposing is if you have that, then we want to do what's called phase 1 cleanup, and we're going to get into that in just a second here, I believe. Well, actually, right before we get to that, the other way you know that you have this issue that we're discussing here is if you can't take NAD. Mm. The reason you can't take NAD is the following. So you get a SAS storm, it upregulates the CD38. The CD38 leads to NAD destruction. So then you think you need more NAD, but what's happening is you're getting a intracellular calcium release that is activating your inflammasomes, which again is what we look at with Bob Miller, which then leads to IL-1B and IL-18, which you can look on these cytokine panels and see if you have those. That leads back up here to create more of these. Then you get right here, you take NAD or you take anything that stimulates the mitochondria, like CoQ10 or PQQ, sometimes methylene blue, and you go right here, back here. So that's just basically feeding into the cycle. And then the more NAD that you take, the more cytokines you're making, basically.
Wow. Okay. Interesting.
Yeah, and this is pretty well. This is not proven in like a clinical trial, of course, but the data dots are all connected there as to exactly how this happens and why it happens. So what I got here is if you're a patient, if you take NAD or someone gives you NAD and you got an IL-6 that's elevated, you're going to get a calcium-mediated inflammatory storm through that inflammasome activation that's called NLRP3 activation. You're literally fueling the fire. So all these people are like, oh, you need to take NAD and muscle through it. You'll feel better. If you feel miserable taking it, you feel miserable the next day, it not only is not good for you, it is actually bad for you. You are making things worse. So if people are selling you a lot of NAD that's making you worse, this is not no pain, no gain. When you're in the chronic business industry, if you're hurting, you're hurting. It's because something is going awry. Stop it. Is what I tell my patients, right? Very simple. There's a lot you have to push through, but if you're getting a lot of pain with treatments, that usually means the treatment's not so good for you, honestly. So here's a visual representation of that. Cellular senescence leading to CD38 upregulation, leading to NAD depletion, leading to activation of these inflammasomes, and the cycle just keeps repeating itself.
Fascinating.
And this is just another way of looking at exactly what I just said in a little more detail. So for all the scientists out there and all the nerds who want to go through and look at, the why and how behind what I just said, that's there for you. I'm not going to repeat it all. You can take a screenshot there if you want. This is really interesting. These are all the diseases that are worsening by inflammasome. So this is the name of what we call inflammasomes, NLRP3. So these are all the diseases worsens by NLRP3 activation. Or another way of looking at this, these are all the diseases worsened by the cytokines IL-1B or IL-18 elevated. Pretty much all the major chronic diseases. So we know anything. So we go back up here. Anything that's leading to this right here via these pathways is making your illnesses worse, making all of these worse. So anything and everything that's making these worse, you're going to get these. So if you do test panels and you've got these elevated here, you have to be really careful. And if you don't have some of these, that you figure out why before you have more of them. Because a lot of people now have long COVID. This is the reason why. A lot of people have multiple mast cell activation syndrome. And this is the why. But look, we got diabetes here, atherosclerosis, fibromyalgia, migraines, depression, bipolar, Alzheimer's, Parkinson's. These are all underlying all chronic diseases. And so finally, we get to the point. And sorry, there's a lot of science there, because otherwise you don't understand why we're giving you the treatment. So why does the exercise harm our patient? And this is because lactic acid is building up. Okay, so let me walk you through this. We got these senescent cells. We just talked about those. We got dysfunctional mitochondrial. What a dysfunctional mitochondria release resting high lactic acid. You got high lactic acid, you go out for exercise, your lactic acid gets even higher. That means your tissue pH goes down. Guess what that does? That damages the DNA. It destroys your NAD even more. You get more reactive oxygen species. Guess what that does? You get more senescent cells created that then make all of these cycles just keep cycling and looping all around back and forth, leading to more mitochondrial dysfunction, more fatigue, higher resting lactate. So for people with a lot of pain at rest in their muscles and tissues, this is not like a joint pain we're talking about. This is like a muscle pain. So muscle pain that gets worse with exercise or even at rest if you're really, really ill. This is the reason why. So here's all the mechanisms of how that happens. We probably don't need to go into all of this. I kind of give a detailed overview already. Your tissue's acidified, autophagy shuts down, the NAD is depleted even more, reactive oxygen species go up, you get pseudo-hypoxia or outright hypoxia, meaning your oxygen is dropping, then the mitochondria collapse and get even worse. Mm-hmm. So you can measure this. You can measure lactic acid levels. So this is what I was referring to earlier when people are pushing through pain with exercise. That's fine when you're 18 years old and you're at the gym and you're healthy. Like, yeah, you have some pain with exercise. You're breaking down muscle. It hurts for a little bit and comes back. But if you're recovering from a chronic illness, you will have to go through some of that. If you exercise, you get to make some pains, and then next day you feel a lot better. That's one thing. You're building up through that. The opposite, though, you're making it worse if you've got these cytokines elevated and you're doing the same thing. So you're pushing through is actually counterproductive. So what I'm proposing here, and this is probably what most people really want to hear, is what the hell do we do about it? So 3-phase mitochondrial renewal we'll talk about here. So the first phase is like remove the senescent cells. Second phase is fuel, like restore the mitochondrial function basically. And the third phase is optimize the mitochondrial function. So the phase 1 is senolytics, basically. So here's a list of senolytic herbs. There's several combination formulas you can find on the market that have combinations of these. These are all working a little bit differently as far as the herbs go. They're working on different senescent pathways, different senolytic classes, we could say. So that's why you'll find combinations of them. I find these can help some people. For most people, by the time they get to see me, these usually aren't helping them enough, we could say. Senolytic medication. So dasatinib in the US is FDA approved, and this is the combination that's been studied by Dr. James Kirkland at the NIH and Mayo Clinic. So the dasatinib with quercetin is the most studied combination. I could be mistaken. I think it's 90 plus studies ongoing right now in so many different classes using senolytics, and I think most of them are with dasatinib. So this is the main one being studied. Is FDA approved as a chemotherapeutic agent. Why the heck could this be a chemotherapeutic? Well, we covered that earlier. So a lot of those growth factors and other factors that are being released by senescent cells are cancer causing. So when you're lowering this, you are potentially lowering some of those cancer causing senescent cells. I will caution you, when you're younger and you're healthy, you don't need senolytics. You have senescent cells when you're younger and you're clearing senescent cells, you don't need this. So just to be clear, these are potential treatments. These are none of these are like proven. These are all highly experimental, and they are not for people who are young and healthy. These are for ill people or older people, because when you're younger, the senescent cells are actually doing probably their job correctly. The problem is when you get to that later point in life and they start going up that exponential curve and they're rising too much.
Yeah, exactly. We do all need some level of senescence.
Exactly right. They're helping with wound healing, and they're actually helping with cancer prevention. So the problem is when they become out of balance and our immune system can't maintain that balance. Exactly. The other thing I use a lot of, FOXO4-DRI, that's a peptide. This works on the P53 pathway. This is injectable only. This was founded at the Buck Institute in Northern California. They say they're doing clinical trials on it. I do not know why they're not doing more. This is as far as I can tell, this is preventing most types of cancer.
Yeah. Yeah.
Preventing it.
Yeah.
It is not inexpensive. It is expensive. It has to be made a certain way. It's really hard to make it, according to the chemists I've talked to. There is no such thing as inexpensive form of it. I've even been warned by chemists. They're like, if anybody tells you they have it for cheap, then it might actually be harming you. So you'd be very careful there and warning. And again, it is experimental. It's not FDA approved. So it comes with that. There is another, these are others. This is another medication that has senolytic properties. I'm not even trying to pronounce it. Azithromycin does have senolytic properties. So this is why some people with chronic lung illnesses and other things, they will give them azithromycin chronically, not necessarily to kill infections, but as an anti-inflammatory and senolytic. Mm-hmm. The peptides here, FOXO4-DRI. I've got some of these other here. These are, I think I wouldn't put these more as senolytic. These are more like used with senolytics. So I wouldn't call these senolytics though.
If you put humanin in there, I thought humanin had a sort of decent senolytic.
Yeah, I would. Yeah, I would. I was making this sort of an intro talk. In the next talk, I was going to go into more detail on some of those other peptides. So this is not an all exhaustive list, Fiona.
Cool. I know hardly anyone uses humanin anyway. It's not a very popular, man.
Yeah, exactly. Yep. So phase 2 is simple. Like, okay, what do you do when you're senescent? So you do this for a while, and I think I have a little slide later. We go into more dosing, so I won't cover all that yet. Okay. Phase 2 is the fuel restoration. Like, okay, after you kill the senescent cells, then you feed the mitochondria. You don't want to feed ill mitochondria, otherwise you make more ill mitochondria. And I'm using ill mitochondria for the mitochondria that are basically in those senescent cells that are zombie-like themselves. Mm-hmm. So to enter phase 2, you need to have normal interleukin-6, or if you get a cytokine panel, mild elevations of maybe 1, but no more cytokine. You want to have lower lactate to pyruvate ratios, and these are tests you can get. Or the other way to say it's just low lactate levels. And hey, you can at least walk around the block and not be too tired. If you're getting post-exertional malaise from walking, then you're by definition more in that phase 1 category for most people. Mm-hmm. And I put here minimum of 8 weeks on that phase 1. Most people, it's probably more like 6 to 12 months.
Yeah, wow. It's a long time for people that are chronically ill that want to get better quick.
But in my experience, people, when you start this phase 1, if you get this dialed in, you start feeling a lot better quickly.
Yeah, and that's exactly right. If you put that foundation, you do it properly, you're going to springboard up the other end so much better. Yeah,
but I try to, and you might already be making cells that have better mitochondria too. I mean, these are the things we don't know, right? Like once you clean those zombies out, maybe you're already getting some better mitochondrial function, but. So if you still have too many senescent cells, if you start fueling NAD, you're just going to be back to where that's why I'm saying 6 to 12 months, because, say you clear 50% of those senescent cells and you start, you get your NAD at a high dose, the next thing you know, you're going to be back to where you were, back yo-yoing again. Mm-hmm. So phase 3, optimize. This is where, Fiona is very good, specializes in the peptides for it. This is more where I put the human down here, but this is where also you're looking at epitalin, though I will also use epitalin in a lot of those phase 1 patients. So I will do that. But, so these are definitely not hard and fast rules. There is a lot of variability in these different modalities you can do in this phase 3. But the main thing is, hey, can you exercise, like zone 1 exercise and not have fatigue? After 24 hours post-exercise, you're back to baseline. Are you having sustained energy, at least on most days? Maybe not all days, but, most of the time you're getting sustained energy. And did you finish, the first 2 cycles above, the phase 1 and phase 2?
Yeah.
Here I go in a little bit more detail on the herbal senolytics. So fisetin does cross the blood-brain barrier, so it targets CNS senescent cells. I haven't used, honestly, fisetin a lot. I tried it a bit personally. I didn't get a huge response with it, so I kind of just shelved it.
Same.
Quercetin, everybody can benefit because it stabilizes mast cells. It's a senolytic. It has. This is why it was a big COVID protocol, is because COVID stimulates senescent cells dramatically, and so quercetin in it, and then those cytokines are just creating a more fertile environment for more viral replication too. So quercetin is really a huge. What was that, Fiona?
That's that cytokine storm that people are talking about, right?
Exactly. So quercetin was helping lower that cytokine storm. Now, I've personally done when I've gotten COVID, I've taken dasatinib with quercetin. It definitely stopped that COVID very quickly. Urolithin A is a mitophagy stimulator naturally produced in the GI tract. Spermidine enhances autophagy. Curcumin, I don't use that too much. Green tea extract, I don't use that too much. Apigenin, I don't use this too much. A lot of these I don't use this too much, unless they're in a formula. Like I do use a few formulas, but most of the people I use the formula zone are people that are not that ill, or, don't have too many major symptoms, or they have really bad symptoms, and I'm concerned the Senolytics might be too strong for them.
Yeah, okay.
So here are the protocols that I use. So dasatinib with quercetin, this is the combination, again, studied together, those two together. So this targets senescent immune cells, T cells, NK cells, macrophages, fibroblasts, endothelial cells, and these SAS-producing inflammatory cells. Dasatinib works on these pathways. I'll let all you guys who want those details take a look at that. And the typical dosing that Dr. Kirkland uses is 100 milligrams of dasatinib with 1,000 to 1,250 milligrams of quercetin over 3 days, every 2 to 4 weeks. I think he traditionally does it every 4 weeks. I started using it a little more frequently personally, and with some of my patients who can get big benefits and then kind of wears off after a couple of weeks, we started dosing a little more frequently.
Oh.
Warning, let me see if I've got this warning. I'll go over the warning in the next page. FOXO4 DRI peptide. So it's working pretty much on all senescent cell types. This one does not cross the blood-brain barrier. Dasatinib does. So we'll talk about that as far as side effects go, because that plays into side effects a lot. FOXO4 DRI, as we mentioned, really hits those cancer-causing senescent cells and neuronal senescent cells. Actually, this is a mistake. It does not have better blood-brain barrier penetration. That's an error on my slide there. Everything I looked at said the FOXO4 DRI is way too large to get in the blood-brain barrier across, even if you have leaky brain.
Okay, I know it's a bulky molecule.
So what I've learned is what I've speculated is the reason a lot of people get neurological benefit from this is just from the systemic reduction of the cytokines peripherally that are affecting the brain.
Okay.
That makes sense.
Yeah.
FOXO4 DRI is injection only. Typical dose is 5 to 10 milligrams injections, like 3 days a week, like Monday, Wednesday, Friday, every 1 to 3 months. It is more expensive. Dasatinib is quite expensive also, but you can get this compound, and that brings the price way down. And so to compound it, the dasatinib with quercetin is much like 10 to 20 times cheaper. FOXO4 DRI does burn, by the way. It'll burn for hours after the injection.
Oh, I've never had that issue with Fox.
No? Yeah, it burns. Some people will mix a little BPC 157 in with it to lower that burn. But yeah, it definitely stings me for quite a while.
You're right. Like a GHKCU sting or worse?
Much worse.
You're right. Okay.
Much worse. Yep. Like a bee sting for like 2 hours. Yeah.
Oh, you're right. Okay. Right.
Yeah, so that's normal. I've had people like, ring me after a Foxo4 DRI injection, and yeah, just let them know that's normal.
Okay.
Um, so yeah, let's talk about safety here. So in phase one, which is the use of the dasatinib with quercetin, so these are just some of the clinical trial results from Dr. Kirkland's network. He's had improvements with diabetic kidney disease, interstitial pulmonary fibrosis, which is basically considered to be one of the worst illnesses you can have. It's a progressive lung fibrosis that no one's ever found any treatment that did anything to it except for this.
Yeah, wow. Okay.
As far as I know, this is the only treatment that has ever done anything, and it improved the 6-minute walk distance in all the patients. I would speculate that if you got people earlier in this disease, you probably would have a lot of benefit with this combination. You don't want to wait. If you've got this issue, you probably want to get started sooner rather than later. If he's Dr. Kirkland's noticed mild cognitive improvement, that's his impairment, just in 6 weeks with the dasatinib quercetin. Again, as I said earlier, over 90 active trials right now. There's a big warning here. The first time I took this, I got like two-day migraine, like worst of my life. So if you have a leaky brain, which most people with chronic illness do, the dasatinib will get in your brain. It will kill those zombie cells. And if you don't have great lymphatic drainage, you don't have great lymphatic movement, if you don't have great craniosacral liquid movement, right, fluid movement, which most people with chronic illness don't, you're likely to get a headache, like a very bad headache. So I suggest starting with very low doses of these. I'll start patients now with like 10 milligram dosing.
Yeah.
20 milligram dosing, 25 milligram dosing. I rarely start with a 50 milligram dosing. Clinically, you can get problems with your blood count. So typically you want to get some CBCs just to make sure. I haven't had any patients with that or liver enzyme issues.
I have.
Oh, you have? Okay. And what?
They clear very quickly, like 2-3 weeks, they're back to normal.
Okay. Good to know. And what you don't want to do in taking this, of course, don't take NAD supplements, don't take stimulating peptides for your mitochondria, and you don't want to be exercising. This is not the time for intense exercise. So how do you decide on which ones to use? This is how I go about it. I often will start with this one because it's oral, it's not injectable. It does target a lot of the immune senescent cells causing inflammation. It does also lower mast cell production. This is in the literature. It inhibits actual production of mast cells. So when I had a really bad mast cell activation syndrome episode, I discovered this. I was like, I found this in the research. I was like, why am I feeling so much better than the dasatinib? I was taking it weekly because it helped the mast cells so effectively.
I remember when you were doing this and you were telling me about that.
Yeah. And so I've continued to do that. So, Dr. Kirkland, he doses it every 4 to 6 weeks, but a lot of chronically ill people with mast cell activation, they will notice a bigger improvement taking it more frequently. Okay. Foxo4 DRI patients, I found a lot of people with more neurological symptoms feel better with it. When I take this, I feel like my IQ is 10 to 20 points higher literally the next day. For whatever reason, I think it's just because of that the systemic lowering of cytokines. What I typically do is the following: I start with one for like 3 months, and I switch to the other one for 3 months. I have not really never had. I rarely do this. Most people don't need this. I personally do this at times, but meaning the combination where you do one month or do one and then 2 weeks later go to the opposite one. But most patients do so well on these, I haven't had to do that.
Okay.
So, how to know where you are again. So if you've got high cytokines and they get better with the senolytics, then you can consider start going to those mitochondrial stimulants in the mitochondrial fueling phase. Things like CoQ10, PQQ, methylene blue, et cetera. Whole current phase, when the biomarkers aren't improving and you're not feeling better typically. And if you're moving too fast, if you get worse, you think you're doing great and you start exercising, you feel worse again, then you go back to that senolytic treatment phase for a bit longer. And this is what I was just saying earlier. I know this is so hard when you're ill and you've been yo-yoing forever and you're type A, but patients in the clean phase present months of setbacks. Rush the sequence, restart the sequence. This is true. If you look at the, like I said earlier, if you get a large reduction of senescent cells, but then you do the things that make them come back, well, they're going to be back. You really are starting over. Sorry to be the bad news there, but I've lived this. I know it well. So these are the things, and we're not going to go into this much. This is a lot of what Fiona covers in all the other great podcasts you have, or all these other things to do to fuel the mitochondria, all the supplements, all the peptides, all the things. There's a lot of information on this. This is just this was a basic slide I put together for a lot of doctors who weren't using a lot of such treatments in their practice, but I know you are, and I know a lot of your listeners already know this. The other reason I put some of these things there is just also, hey, if you've tried these, again, if you get worse with CoQ10, if you get worse with PQQ, it's just like the same with NAD. You're probably fueling some bad mitochondria that are creating reactive oxygen species, cytokine production, et cetera.
Yeah.
This is when also you want to look at things like MOTS-c, humanin, SS31. You look at peptides that are going to help you metabolically, like glandicort or adrenal peptides, pancreas peptides, liver peptides. You're trying to get the organs all renewed.
Yeah.
That's yeah. Sorry, Fiona, go for it.
No, I was going to say I get amazing results using the bioregs.
Exactly. Do you use them earlier, or how do you time them when we're looking at something like this?
I use the cytogens, so the synthetics, much earlier because they're fast and quick, and so I use, generally it's Livergen, and because there's no cytogen version for adrenal, there is for pancreas, so I might use the liver and pancreas very, very early on, and if there's microclots with long haul COVID, I might use Vesigen. So I'll use them very early on, then go through the other stuff, and then put in the Cytomaxes, so these ones, the orals, later.
Okay. Thank you. And then phase 3. This is, again, this is what all of you, a lot of your podcasts are on. All these advanced programs, advanced peptides. This is when you're getting into all the things. I
love this light-based quantum mitochondrial communication. I'm going to steal that. That's such a great sentence.
Yeah, and of course, these aren't all written. Some people will be paradoxical, like they'll still be in phase 1. They have a lot of senescent cell burden, and they may do great on one of these things on this list, and you're scratching your head going, why? And sometimes you just can't figure it out. We don't know enough. We really just don't have the capacity to connect all the dots. This is why I use AI, and while I'm building AI models now, because I'm learning the pathways by oh, wait a second, I know all those pathways. Like in the patient with the ivermectin, okay, we know these pathways are happening. Why is she getting better? And this subset of symptoms getting better when she takes ivermectin. It must be related to some of these genetic pathways, and lo and behold, works on that one pathway. Yeah. So the real issue is there's too many dots for a human to connect, especially in the time frame that we're given to assess these. The other thing I wanted to say is, hey, for people that if you don't have a doctor who will prescribe these, if you don't have the funds to take these because they're not cheap, I get it. I've been there. What can you do that's cheap and easily available? The most important is circadian rhythm optimization.
Amen.
So sunrise exposure, getting the sunlight in the morning, especially. that early morning sunshine in your eyes and on your head is going to help you tremendously. Getting 7 to 9 hours a night in a cool room, grounding while you're outside in the sun, grounding as much as you can, and having stress reduction. This is the best thing you can do to induce these autophagy and mitophagy yourself, basically.
Yeah, thank you for going through that. It's so important. These things are just should be pillars. Yeah.
Yeah, absolutely. And then on phase two, when you want to fuel things, the inexpensive way to fuel things, it's also taking out senescent cells is fasting. So the fasting also can fit over here in the clean area if you can tolerate it. So fasting is proven to stimulate autophagy and lower senescent burden. So that's the cheapest thing you can do because you're not having to pay for food. So I laugh about it. I used to fast a lot, and it's one of the best things you can do if you know how to do it and you're doing it correctly for yourself in the right way.
I IF every day.
What's that?
I do intermittent fasting every day. So
You do, yeah. I find it to be, I do. I've learned to like change diet with sort of like in a circadian way. So just like, hey, eat your bigger meals earlier in the day, lighter meals later in the day. And that has helped tremendously. So it's more like a circadian eating rhythm with the intermittent fasting. And then optimizing, if you're over here in this category, this is where like the HIIT therapy, high intensity interval training, strength training, cold therapy, HRV optimization come in. And again, if you're in any of these phases, and you're trying to get the next one, and you have any of these, then you're moving too quickly. Post exertional malaise, sleep disruption. This is a big one. I have to, I know I've said this 2 or 3 times, but I repeat myself sometimes because these are the things I see that people kind of ignore. Oh, doc, I'm back exercising. I feel good, but I'm not sleeping good. I wake up tired. Well, guess what? You're moving too quickly. Getting tired in the afternoon, well, that's your adrenals. Your cortisol is being burned out. You're moving too quickly. Overwhelmed by daily activities, emotional stressors in your life. Well, that's not good either. So these are all the things sometimes slowing down gets you to the goal faster.
yes.
So that's everything there in one page. I think we've already covered all that. I think we're pretty much at the end here, Fiona. Okay, yeah. So here's just differential diagnosis to look at. So these are senescent cascades we're looking at. They're usually from an infectious trigger. They get worsened with NAD supplementation, usually have cytokines elevated, lactic acid elevated, and they get poor response to standard protocols. I put this here because you need to, for all the doctors out there, you want to make sure you are making sure the patient doesn't have some other serious etiology going on, like cardiovascular, pulmonary issue, hormonal issue, basic vitamin nutrient issues like low iron, B12, low B12, or major autoimmune issues. And then I just reviewed here why to choose which one again. We've already reviewed that. And again, for safety reasons for all the doctors out there. Pre-treatment for using Senolytics, make sure you get a CBC, liver kidney function, get the cytokine panel, get lactate pyruvate ratios, and know your patient's exercise tolerance. Then here's the monitoring during treatment. I put here biweekly inflammatory markers. Sometimes that's a bit aggressive. For probably practically every 2 months is probably about as often as you're going to be able to get these for most patients. But this Herxheimer reaction is a big deal at the beginning. You're going to have a hard time helping a patient get better if you give them a large dose of dasatinib and they feel miserable for a week.
Yeah.
So, you have to stop the senolytics, of course, if you get cytopenia, liver enzyme elevation, or if they're just getting worse. Rare though it may be, this is not going to work for everyone. There are some scientific references here. I don't have them all listed, but there's quite a few there for you guys. Oops.
So useful for people. And I don't know whether it's just I don't know. I don't know whether it's because I work with doctors that just refer me all their hard cases to put in protocols, but that this is the patient that I see day in, day out. I don't know whether, it'd be interesting to hear from you, whether you're seeing a rise of these patients. I definitely feel like I am, especially with mast cell activation, and then they're sort of autoimmune-ish without a fixed autoimmune disease. Generally all have a history of Epstein-Barr. I'm actually finding a concussion in their history as well seems to, be a tipping over the edge, and then we get all that sort of other stuff. But yeah, again, I don't know whether it's just what I'm seeing in clinical practice, but this is what I do day in, day out. It's these patients. And like you say, they can be particularly tricky to get well, especially once you start getting them well, they get very excited. I always have to tell them to bank the energy, as I call it, savings. You want to keep 50% in your savings account to continue to get better, because they like to go out and spend everything at once and then trash themselves, and then I got to go back. So I have to have that talk over and over again, because some of them have been bedridden for 7 years, right? So then they're like, if they get any energy, they're off to the races. So, but it is interesting. So I'm seeing a rise in these patients. Again, it might just be what I've been sent from the doctors that I work with. But are you in clinic, are you seeing an increase in these sort of patients?
Yeah, I mean, also, me being the specialist now and weird things, all these weird things find me, but I think no, presenting this at the conference is pretty much what everybody's getting, and this is just on the rise more and more. What I didn't put in the slideshow, which I do have in the book, is the connection between all of this and COVID, the connection between all this and the COVID vaccine and the vaccine injury. So the reason there's one reason for all of this, and it's the COVID vaccine.
Yeah, I didn't want to say that, but it's just, yeah, and it's my patients.
I'm no longer afraid to say that. I say it crystal clear. Okay. I'm writing about it. That's the issue, and and if you got it, for all the doctors out there and for the patients out there, you got to make sure that that is addressed. If you're having these senescent cells, one of the main driving variables for them is persistent infection and persistent vaccine injury. Sorry to interrupt.
Yeah, 100%. And for me, the bulk of the patients that I'm being referred by very good integrative GPs around the world they're young. Like I had a guy yesterday that was 23 and has been, and you're like, when did you get back? 2019, 2020? I'm like, did you have a COVID infection before? And they had all the stuff sort of lined up before, stacked, but they were okay. But you're right, as soon as we tick into that time era, whether it was a vax injury or whether it was an infection, I have patients that never had a vaccination but copped COVID, and I've got a couple of them that are really, really sick with spike proteins just going out of control. So, yeah, it's definitely what I'm seeing too, and it's sad. Like I say, these really young people that have been just wiped out in bed for years.
Right? Can you get spike antibody levels, COVID antibody levels?
I can't find anyone that's testing it. In South Africa, there's an amazing doctor doing great things, and they test it over there. A lot of my patients will go in and out of South Africa because he'll do all the microclot testing and do that sort of treatment protocol. So I've got a lot of patients going in and out there, so we can get it done there. I haven't found anywhere in Australia in my lab, so I can't get it done. I need to talk to some of these doctors, but I've never seen it on a blood test in Australia. I can see it in the US. Do you get it done over there?
Yeah, I'm using it now mostly just to show patients what it's causing. If it's persistently elevated, especially LabCorp measures it up to 25,000, and then they just say above 25,000. If it's above, I had a patient today, she was at 11,000 and she was feeling a lot better. So that's in that middle range. Everybody I've tested was in like greater than 25,000. Basically there, and they need plasmapheresis, need massive treatment to get the clotting down, need to get the from the enzymatic therapy like nattokinase. But the full regimen, I've gotten really good results with just nicotine patches, nattokinase, this product called foreign protein cleanse.
Yeah, I've got a patient on that one.
Yeah, I find IV vitamin C works well. IV ozone or EBU can work very well. The ultraviolet light IVs work very well. So for sensitive patients who can't tolerate Anything else, those ultraviolet and red light IVs, there's several different brands of them, work exceedingly well. And I'm one of the most sensitive people that I've ever had to treat. And I basically had to treat myself to get through all of this. And that's the only treatment I've ever found that never flared me up.
Oh, interesting. We're preparing for a lot of inusphoresis here in Australia because we've got a good inusphoresis across in Perth. But yeah, which is great. But I'm literally going across in 3 weeks. I've got a Christmas party over there. But while I'm there, I'm having some ozone and infra ozone UVB light blood transfusion stuff going on just because
perfect.
So I'll just check it out.
Yeah, I find it's so nice. It's such a good therapy. I mean, I'm thinking of just buying a device to have personally, just so I can call a nurse to come over and give it to me wherever I'm traveling. It's a small little device, because right now there's not a lot of people that have those. But for if you take that conversation you were looking at earlier, we had at the very beginning, what's driving this? What's living inside those senescent cells? There's infectious agents. It's being perpetuated by infectious agents. It's being perpetuated by anything that makes senescent cells worse.
Makes sense.
For me, when any of these people walk in the door, it's a vaccine injury until proven otherwise, for the most part.
Yeah. No, I get it. Yes, crazy times that we're living in. So good information for people to have and for people to take on board. And of course, I'm seeing in patients like this, we see more tubule damage. We might not see changes in the EGFR, but if we're measuring things like beta-2 globulin or retinol binding, I'll see changes in those in the urine. So we know that there's early tubule damage before we might start to see really big changes in rises in creatinine or changes in EGFR. Or sometimes you've just got the EGFR, just relating it to kidney stuff, you might just see the EGFR just, hovering in the 80s. A lot of my guys with this will have an EGFR high 80s where it never gets flagged. But if you go and do those particular markers for tubule damage, you'll see they've got very early tubule damage, which makes sense. You think of all these SAPs, SASP, and that makes sense to me that they'd be causing micro damage inside the tubules before we might see big changes to the EGFR and things like that. So, Do you want to add anything before I wrap this up?
No, I don't think so. Yeah, I'm probably blown enough circuits.
Probably getting close to your bedtime. Well, as always, thank you for joining me, Dr. Morgan-Camp. I'll put your details in below. So if anyone wants to know more about what Dr. Camp does, you're still treating patients, aren't you? I know you're really busy building out some good technology.
Yeah, very selective. Right now, we sometimes will have 1 or 2 leave, very selectively though. That's why I'm releasing this book. I want to make sure in lecturing more to other doctors, so other doctors get a better idea of what's going on. So that's more and more where I'm going is, in a perfect world. So anybody out there who's got a doctor who's willing and able to learn, the best way to use me would be to have your doctor have a consult with me, which you could come to. So that's what I do with a lot of my patients. I find experts and I take my patients to them, then I get to learn, and then I can still be the patient's doctor. But I've yet to find anyone come to me with that offer, because most people, it's ego related, right? They don't want to, they got to be the top guy for their patient, when actuality in the real world, your patient really, I think, respects you if you're willing to say, hey, let's go see somebody else and listen to their opinion and then integrate that into what we're doing. What I found is my patients love that, actually.
Oh, no, I find it as well. I'm really lucky. I've got a team of about 5 or 6 doctors and specialists where a patient will have 5 or 6 of it. I'm just doing, bioregulator protocols, but the doctor's doing this, and then they've got the acupuncturist doing this, and they've got the neurological osteopath. And it's a fabulous way to practice. I've got integrative pharmacists on board. It's great. I love it. It's the best way to practice ever.
Yeah, and exactly. When you're part of a team that's coordinated, that's the real thing. So I think that's a good thing to close with. I mean, that's how you get better. You got to have a team. You can't
100%.
You got to have a team,
Yeah.
And without that team, and sometimes you've got to be the team leader, so to speak, for the most part, but you got to find people that you can trust when you're not able to think clearly enough for yourself too.
Yeah, takes a village, isn't that right?
Absolutely, absolutely, absolutely.
Dr. Morgenkamp, as always, it's a pleasure and a joy. Thank you for your wisdom and your genuine care about patients. Definitely when the book comes out, let us know. We will make sure we put all the details in below. I'll put in your website anyway, in case anyone has a practitioner that is eager to learn. They can hook up with Dr. Morgenkamp and do that as well. If you want to know more about what we do, head to www.kidneycoach.com. You'll also find us on social media. Make sure you hit subscribe and like, and that way you'll get notified anytime we put up more content. Any questions for Dr. Camp, put them below. And thank you for being part of our community. We look forward to seeing you all next time. Bye.